Professor in LG Institute of Engineering and Technology in Department of Electronics and Communication. This video is about subject Microwave Engineering. So, in this video, we are going to learn about various active microwave components. In the last video, we have seen about the various passive microwave components. So now, the microwave solid state devices. Under this, we are going to learn about the semiconductor microwave devices. As we know that all the semiconductor microwave devices or the diode, they are made up of the semiconductor material and which uses the property that is the junctional property. So whenever we want to change the designed property, we need to play with the junctional property of the semiconductor material. So now these are the various diodes, that are the Varactor diode, step recovery diode, parametric amplifier, tunnel diode, Gunn Diode, pin diode, Schottky Barrier Diode. So these are the various diodes. Now we are talking about the microwave frequency. So frequency is the high. So as the frequency is the high, okay, the junction, the semiconductor junction, that has to make the thinner. Now as we know that the junction that is the thinner, then it is very difficult to obtain the high power. So that is why the difficulty is there. So that is why we need to go for some other thing which is not depending onto the junctional property of the semiconductor material. So that is why it is divided into the two different parts. One is known as avalanche transit time devices and other are known as the bulk devices. So these two categories, avalanche transit time devices, they are designed to achieve the minimum transit time, and the bulk devices which uses the bulk property of the semiconductor material. So now there are the four different categories. One is using the bipolar junction transistor, field effect transistor, transport electron devices and avalanche diode. In the bipolar junction transistor that can be used, then the hetero junction which is made up of only one material, okay, that is the homo junction transistor, okay, then the heterojunction bipolar transistor which is made by using the two different material, okay, the tunnel diode which works using the tunneling effect, okay, and the field effect transistor which uses the JFET, MESFET, okay, high electron mobility transistors, then the charge couple devices, transport electron devices, that are the Gun Diode, that ISA, LSA diode, INP diode, CDTE diode, avalanche diode, okay, avalanche transit time diodes, okay, impact diode, trapped plasma, avalanche triggered transit time diode, okay, so Varactor diode, okay, so these various are the microwave diodes, okay, so these are the four different categories. Now while we are making the diode, the choosing of the choice of the substrate, okay, how can you choose the substrate of the material that which provides you the high mobility of the electron? So that kind of the substrate that we can choose. So here the silicon or the gallium arsenide, okay, that can be used. So most of the microwave devices, they are fabricated on a GaAs substrate because of its high mobility. A silicon substrate that has the advantage of the low cost and the high yield, and the drift velocity, that is the electric field, okay, multiplied by the mobility of the electron. So this is about the basics of the various solid state devices. Microwave diodes, in which the microwave diodes is much more than just a two-element device which has the limited capabilities. So many devices, they are developed using the non-linear IV characteristics, that is the current and the voltage characteristics, and the CV characteristics, that is the capacitance versus the voltage, okay, characteristics of the PN and the Schottky Barrier Diode. Now, according to the nonlinear IV characteristics, we have the following advantage. That is, we can go for the frequency mixing applications, harmonic generation, the switching, modulation, limiting, detection, everything we can. And using the nonlinear CV characteristics, frequency multiplication, voltage control oscillator, voltage tune filter, frequency conversion, harmonic generation, parametric amplification, we achieve using this property of the diode. Okay, so Schottky barrier junction of the semiconductor and the metal. So now we are going to discuss about the first diode, which is the Schottky Barrier Diode. This Schottky Barrier Diode, the symbol, you can see that this is the symbol of the Schottky Barrier Diode, and the construction of the Schottky Barrier Diode you can see. So in this, here there is a N type, okay, N type of semiconductor is there, and at the one end there is a metal contact is there, and at the cathode, okay, the ohmic contact that is provided. So that two node, they are known as the anode and the cathode. Okay, here again you can see that whenever the lower voltage that is applied, okay, and at the particular lower voltage, okay, what we have? We have, okay, the characteristics, okay, that is the about the current is the mode, okay. So the one semiconductor region of the PN junction diode that can be replaced by a non-ohmic rectifying contact, a Schottky contact that is easily formed, okay, by using on an N type of the silicon. The metal region that becomes the anode, and N plus region that is added to ensure that the cathode contact is ohmic, and the silicon diode that turn on at the lower voltage, okay, and then the PN junction diode, okay, and the internal charge storage, okay, that is again the reduce under the forward bias. Now when we compare, okay, about this is the PN Schottky diode, the symbol, okay, and you can see over here that whenever the nonlinear IV characteristics of the diode is this, and this is the nonlinear CV characteristics of the diode, that it operates at the very less voltage. So the forward voltage drop of the Schottky barrier diode is very low, okay, compared to the normal PN junction diode, okay, and the VI characteristics of the Schottky barrier diode are very stiffer compared to the normal PN junction. Okay, the features of the Schottky barrier diode that are the low turn-on voltage. When the turn-on voltage, that is between the 0.2 to 0.3 voltage. If you consider particularly for the silicon diode, this is between the 0.6 and the 0.7 voltage from a standard diode. Fast recovery time. A fast recovery time, that means a small amount of the storage charge that can be used for high speed switching applications. Low junctional capacitance, that it occupies the very small area after the result obtained from the wire point contact of the silicon. And that is why the capacitance levels that are very small. So, next this is about the Schottky Barrier Diode. Now the next is the Varactor Diode. In the parametric amplification of the microwaves, okay, the Varactor diodes that can be used. This is the symbol of the Varactor diode, which consists of the analog anode and the cathode. This is the characteristics of the Varactor diode. As you can see that as the reverse voltage that is very small, the capacitance value that is more. While you are increasing the reverse voltage, the capacitance value that can be decreases. So this property of the Varactor diode that can be used in the parametric application of the microwave devices. So this is again the construction of the Varactor diode. While you are applying the low reverse voltage, bias voltage to the Varactor diode, there is the narrow depletion region which is formed and which provide us the large capacitance value. Similarly, here we can see that the high reverse voltage that is applied, this depletion region, okay, that is the narrow, okay, and it provides the small capacitance value. Okay, so this way the Varactor diode construction is this. It is made up of the P type and the N type of the material. Okay, so this is about the Varactor diode construction. There are the various applications of the Varactor diode, that are the voltage control oscillator VCO in the FM system, in the instrumentation, in the electronic warfare. Okay, so this is the application of the Varactor diode. Now the next diode is the PIN diode. PIN diode, the name itself says that it's like the PN diode, but there is a sandwich, that is the intrinsic material is sandwiched between the P type and the N type of the layer. So it's similar to the PN diode with an intrinsic layer in between, which results in the smaller junctional capacitance. Okay, it is very useful in the as a microwave switch. Okay, so now here you can see the diagram construction of the PIN diode, which consists of the P plus substrate and the N plus substrate. Okay, the width of the P plus substrate, that is the WP, and the N substrate is the WN, and the width of the intrinsic layer, that's the W, and the reverse voltage that is applied. Okay, here it is the equivalent circuitry for the PN junction diode. Okay, so now the applications of the PN junction diode, okay, that is in the communication system. It can be used as a wideband switch, okay, and it is also used as a modulator in case of the communication system. Okay, so this way the various applications like the RF and RTC controlled microwave switches, RF and variable attenuator, in limiter circuit, in the photo detector and the photovoltaic cell, and the RF modulator circuit. Okay, this is used. Okay, so this is about the PIN diode. Now the next category of the diode is the Gun Diode. This is the simple the symbol of the Gun Diode. This Gun Diode is a transferred electron devices and which is composed of only one type of the semiconductor. Okay, it exhibits the negative differential resistance. This exhibiting the negative differential resistance property that is used, okay, in case of the Gun Diode and which works on the gun effect. Okay, and mainly in the Gunn oscillator for producing the microwaves, the Gun Diode that can be used. This is the construction of the Gun Diode. Okay, here you can see that the 2N plus substrates are there, which are made up of the GaAs, that is the gallium arsenide, and between that there is a buffer, and buffer is there, and the anode and the cathode that is provided. Okay, to protect it from the temperature, the heat sink that is also provided. Okay, so here another construction you can see in the diagram, N plus, and between that is a N layer. Okay, and two metallic contacts that has been provided between the two N plus terminal. Okay, here it's characteristics of the Gun Diode. Okay, that is at when the small voltage, okay, is applied, okay, the high value of the current, okay, that can be flow, okay, through the Gun Diode. Okay, so there is a peak point. After the peak point, again gradually the current value that is decreases, and after the point at which, okay, again it starts increasing. So this point is referred to as a valley point. So transfer electron devices this way transfer the electrons into the lower energy level from the higher energy level. Okay, so as the bias voltage increase from a low value, the electron acquires the higher energy and their velocities are increases. So they transit very fastly. Okay, so when the field strength reaches a threshold value, okay, the collision that becomes sufficiently so that the mobility that is reduced, and it corresponds to this, the electron in the lower energy valley that is transferred to the higher energy valley, and due to that it exhibits the negative resistance again. The various advantage of the diode, they are the portable and the small size devices. The cost of the manufacturing, it's low. It possesses the better noise to signal ratio and it immune from the noise disturbances. The Gun Diode that is reliable and stable at the higher frequency. It has the high bandwidth of the operation. The disadvantage of the Gun Diode, that is, has the poor temperature stability and operating current that is higher, and that is why the power dissipation that is more, and the frequency of the Gun Diode is low, below the 10 GHz frequency. The applications of the Gun Diode, that is, they are used in the oscillators, amplifiers, radio communication, military, communication radar application, fast control equipment, in the microelectronics for the modulation of the laser beams. It is also used in the tachometers, in the sensors, for detection, in the tree pass detecting system, indoor operating system, pedestrian safety system. So these are the various applications. Okay, that is why the Gun Diode that is the mainly used in case of the microwave devices. So thank you very much.